I'm a PC. My name is Rob Relier. I'm an architect on the WPF and XAML team. I love making great software to make great user experiences on the client.
And I'm a server. My name's Daniel Roth. I'm a program manager also on the XAML team. I also work with WCF and WF, so I'm a great host for your services and workflows.
So welcome to .NET 4.0 Declarative Programming with XAML. We're really excited today to have the first ever XAML focus talk at a PDC, Tech Ed, or probably anything, maybe. So we're really excited today. This is going to be an advanced talk. We're not going to walk through the basics of XAML. We're going to focus on futures and a lot of new things that we're coming out with in .NET 4.0. We're excited to be here today. Let's get started. XAML's had a great start. The state of XAML in 2008 is strong. We've got 3 XAML vocabularies. XAML vocabularies to help describe user interface, workflow, and electronic paper. For UI, Silverlight and WPF are allowing people to build great user experiences, and they're allowing designers and developers to collaborate together. Workflow has made great declarative coordination of work possible. And XPS has enabled great electronic paper definitions. We've got XAML parsers in several runtimes. In the .NET Framework 3.0, 3.5, we'll see improvements in 4.0. And Silverlight 1, Silverlight 2, and we'll see improvements into the future in Silverlight as well. Within Visual Studio 2008, we've got great designers and XAML support. First generation, we're going to continue to iterate on a great designer, great XAML editor, a great workflow designer. And we also have expression tools that provide great XAML editing as well. This past year, we've published a lot of specifications about the XAML language and these vocabularies. MS-XAML was published in June and defines the XAML language. This is published under the Open Specifications Promise. And so are WPF XAML vocabulary, a 600-page volume of the schema for WPF tags and properties. And Silverlight XAML vocabulary just shipped the same day that Silverlight 2 shipped just a week or 2 ago. XPS's specification has been shipping for a couple of years now. They're now working to move that specification into the ECMA body and working with ECMA to standardize XPS. We're really happy to have open file formats for some of these vocabularies, and we've already seen big momentum for file converter authors. Already in the WPF space, there's a bunch of people in the community and tools who have written converters, importers and exporters from 2D file formats, 3D file formats, Visio, into WPF XAML content. That's exciting. We'll talk a little bit about how we can make that easier in the future as well. But there's still a lot to do, and that's what we're going to focus on today, now in 2008. As we talk to customers, they typically say, oh, I could do this, but I want to do it all in XAML. Has anybody here ever wanted to do it all in XAML? So sometimes we need some things in the language to make it possible for more domains to be modeled, for more things to be possible, for generics, for other types of things to be modeled in XAML. We need to make parsing, saving, XAML, BAML, objects, everything faster and better factored. Effectively, with XAML and BAML, we invented a .NET language to define object graphs. XAML, I think of like C# or Visual Basic, perhaps not as flexible, but they do a very good job of using XML to describe object graphs. And BAML is kind of like IL. XAML is compiled into BAML, at least in WPF scenarios. Because we invented a new IL format, we kind of messed up in 3.0. We didn't make it possible for everybody to use that IL format for a number of scenarios. So we're going to continue to invest in these areas to make sure that the compilers have better error experiences. We catch more errors, we tell you about them, and we make it easier to build and debug things. We're going to work with the obfuscation vendors to give them the API so that they can actually let you obfuscate your assemblies and change the type names in the BAML as well so that your application can still run. We're working to open up the BAML format as well with an API to read and write it as well to enable better localization scenarios. And it'd be great if people could write FXCOP tools that could analyze XAML or BAML or other things to make sure that you're doing good accessibility guidelines and other things like that. Perhaps you have a text box and you want to make sure every text box in your application has an associated label so the correct localization information shows through. That's hard to do today, if not impossible. In whole, the VS team is working to make XAML a first-class language in VS and treat it like a first-class language. They're going to continue to evolve that in Visual Studio 2010 and beyond. In .NET 3.0, we had parsers everywhere. We had a parser in the workflow assembly. We had a parser in the WPF assembly. How many of you wrote your own parsers? I see about 10 hands.
All right.
I wrote my own. It's fun. You can do it in the weekend. At least the first 80% is really easy. But should everybody write their own? Probably not. We should make it so that teams within Microsoft and other teams that want to use the .NET framework can leverage an extensible parser, a performant parser, a parser that meets everybody's needs. And Dan here, for some reason, doesn't want to load presentation framework on servers.
That would be crazy.
We'd like to be able to model more than UI, workflows, and electronic paper in XAML. And we'll talk about that. So that's the talk. We're going to talk about language enhancements. Dan's going to do that. I'll talk a little bit about better, faster parsing, more flexibility of APIs, a new DLL to announce. And then Dan will talk again about some more XAML-ready frameworks.
Thanks, Rob. So let's kick this off. I'm pleased to announce that in .NET 4.0, we will continue to evolve and improve the XAML language by shipping XAML 2009. XAML 2009 makes it easier to author applications declaratively and enables more rich XAML vocabularies. XAML 2009 includes a lot of things, so let's get started. First off, XAML 2009 will include support for better named references. In XAML 2006, if you wanted to write down an object graph in XAML, you could do it, but you had to use domain-specific mechanisms like binding, resource dictionaries, or your own. In XAML 2009, new, we will support representing object graphs out of the box. The new X:Reference markup extension will support both backwards and forwards named references. So we will automatically preserve for you your object instance references. Also, even better, frameworks can leverage the name referencing mechanisms in XAML 2009 to support direct named references. Here in this example, the label's target is now referring directly to the text box by name with no additional markup. You can also create new name-based syntaxes. Here in this next example, I have a write-line activity. This is Windows Workflow. And the text property you can see is an expression, which is a concatenation of hello with the value named first name from the object graph. Built-in types. Some of you may have felt the pain of having to deal with lots of ugly XML/NS attributes, even when dealing with simple types like string and double. In XAML 2009, we're going to make authoring easier. We're going to have a set of built-in types all in the XAML namespace that you can just use. We will support generics everywhere. If you wanted to write an observable collection of persons, say, in XAML today, the only way to do that, really, was to create a new type, like a person collection, that derives from observable collection of person, and then use that derived type in XAML. New in XAML 2009, you can use the existing X:Type arguments directive to represent generic types directly in XAML. Here I'm representing an observable collection, a person right in XAML. No markup compilation needed. Multiple generic parameters, no problem. Generic parameters, also no problem. We will support arbitrary dictionary key types. Today, your dictionary keys pretty much have to be either a string or a markup extension. In XAML 2009, it can be whatever you want, an arbitrary type. Here in this example, this is a switch activity from Windows workflow. This is representing a switch statement. The value that I'm switching on is specified, again, using an expression. The value is this rating value, and I can tell that it's an integer because of the generic, the X:Type arguments attribute is saying so. The cases for this switch statement are simply modeled using the key values of dictionary entries. So in the first case statement, the case is for 10. Now in XAML 2006, that 10 value would have been treated as a string. In XAML 2009, it will be correctly treated as an integer. In the second case, I can actually specify the key in element syntax. So I can put an arbitrary object as my dictionary key. We are going to go beyond method names for declarative events. Today, to specify an event handler, you do so by specifying the method name, you then implement it in code, and then you do markup compilation. So really, you only can use events in BAML. In XAML 2009, markup compilation is no longer required. Here in this case, I'm specifying the method name still, but the parser will look for that method on the type of the root object of the object graph for you. Even better, you can now create a markup extension that returns a delegate. In this case, I have a delegate creating markup extension that's returning a delegate for the event handler based off of some value foo. Of course, I can also write that in element form. It's just a markup extension. You can even imagine that I can handle an event by implementing a workflow. And you won't have to imagine that very long because I'm going to show it to you later in the talk. Better declarative type authoring. In XAML 2006, we have this X:Class attribute that allows you to enable code behind scenarios and create new user controls. Really what this attribute is doing is defining a new type. Here I'm defining a window1 type, and it is a window. It derives from window. In XAML 2009, you can now also add custom properties declaratively in XAML. Here in this example, this is actually exactly how Windows Workflow will define custom activities completely declaratively. Here I'm defining a prompt activity. It is an activity. It derives from activity. And it has two new properties. It has a text property, and it's of type inargument of string. This would be the text of your prompt. And then it has a property named result, and it is of type outargument of string. This would be the value that the user then enters for the prompt. Today, if you want to use a type in XAML, it pretty much has to have a public default constructor, or it has to have some sort of type converter. For example, if I wanted to write down in XAML that I want a date time to represent the specific time of 100 ticks, well, there's really only a string format for date times today, so I'd have to remember how many microseconds a tick is and then figure out what the string format is and how many zeros I need after that, the decimal place. In XAML 2009, you can now leverage non-default constructors using the new X:Arguments directive. This allows me to specify arguments for non-default constructors, so I can just say, I want a date time for 100 ticks. There are a lot of types that you generally also create using static factory methods. For example, if I want to create a GUID, the way you do that is by calling GUID.newGUID. Today, you really can only do that in code. In XAML 2009, we will add support for factory methods using the new X:Factory method XAML directive. Here in this case, I'm creating a GUID, and I'm using the new directive. The value after the dot is the name of the static factory method that I want to call. The value before the dot is the type that that method is on. So in XAML 2000, a lot of factory methods, of course, have arguments. So x:factory method will compose with x:arguments. So we've got a lot of great features coming in XAML 2009. Improved name references using x:reference. Full generic support. Built-in types for easier authoring. Support for arbitrary dictionary types. Support for events without compilation. You can define new properties declaratively in XAML. You can use non-default constructors and static factory methods. Rob, I'm just so excited about all the XAML that people are going to be able to write using XAML 2009.
It worries me, though. It worries me. They're going to be able to do more things now. How are we going to process all that stuff? How are people going to understand XAML?
Well, I mean, XAML is just XML, right? You could just parse it as XML.
Sure, we could try. But there's some problems. When you start with a checkbox in XAML and you have a text node in there, in the XML world, that's an element with text node inside the child nodes. So I can get that. And we map that, XAML maps that to create a new checkbox object. And we figure out that there's a content property, and we figure out that, we've got to put that string inside of the content property of the checkbox. That's cool. Okay, so I could process that. That's great. But then, we also invented this other crazy syntax, right? So property element syntax to do the explicit version of the same thing. Now I've got an element inside of a text node, and that's like, throwing my XML processing all out of whack. So that's weird. Now I also have a third way to set the same property. I could set it with an attribute form. So in XAML, we have these flexible ways to set it because of the scenarios we wanted to enable. We wanted people to not just be able to set strings like this, but also to be able to put rich objects inside of a property and to be able to break out of attributes. But that causes problems because the XML data model is very flexible. Every element has a number of attributes and has a number of child nodes. And CLR objects, they just have a bunch of properties and events and members. They don't have child nodes. Child nodes isn't on object. So where do we put content? We let the types tell us where to put the content. I'm going to demonstrate the XAML data model for you in a XAML pad-like application. The XAML data model is OMV plus types. O is for objects. We have checkbox. That's representing an object. M is for members. We have members like the content.
Well, that's a checkbox on the right. That's that. Oh, okay.
You didn't
that was a huge checkbox.
Yes, it's huge. It's huge. My XAML pad has viewbox built right in.
Wow.
So here, inside of this checkbox, we'll set some other properties as well. We'll set font style equals to italic. Okay, so I've got a couple different properties set on this guy, but it's really hard to tell what we're doing here. So in my XAML pad app here, I have on the left an XML representation. I call this in my little app XML box. Over here on the right, I have objects, the objects that are created. I call that object box. And now what I really need is DOM box.
We should bring up a DOM box.
Is DOM box in the audience? So I'm going to bring up a DOM box.
Oh, DOM
box.
DOM box. Okay,
All right.
okay.
So I'm going to bring up a DOM box here to represent the data model of XAML here. So my XAML pad here has a little diagnostic mode. And I'm able to see that I have a start object here for the checkbox. And I have an end object representation. This checkbox has two members. It has a font style property, which has a value. And member has a start and an end. And this member has a start and an end as well. I hid the name in the DOM box, hides these names, because it's just easier to see a lot of things. It's the content property, so everybody knows this one.
So the green things are objects, and the orange things are members. And the one without a name, that's the content property. Okay.
Exactly. So I can go ahead and select these things. So once again, the data model's object member values. We have start objects, end objects, start member, end member, and values. And I also said it's also OMV plus type. So let's go ahead and press F12. F12 when I've got selection on the checkbox. And this brings up the XAML type. Now in XML, let me flip back for a second. In XML, if I was parsing this representation, I'd get a start element. And the local name would be a string checkbox. And I wouldn't know what it is. One of the benefits that we want to provide for our data model is we want to specify when you get the start object node, we want you to understand the type and be able to ask questions about it. And we want that information to be relevant to XAML processing. So here you can see that there's a XAML type object, and this is just a visual representation of it, that exposes what is my content property? What are all the properties that are exposed here? Are there any attached properties defined on me or my ancestors? Do I have any events? What is my synonym with x:name? What's my synonym with x:lang? All of those things. It's a XAML-based system, and we expose this XAML-based information. I can go take font weight and press F12 there and see that, oh, that's of type font weight, and it was defined on one of my a class called control.
So that's a member.
So this is a XAML member, control.fontWeight there. So adding type information really makes it a lot easier to do a number of scenarios because I no longer need to do type resolution. The system will help you do it for you.
So that's great, Rob. I mean, I like that data model, but how do I actually create a DOM box? How do I process at that level of abstraction?
You're getting ahead of yourself.
Oh, I'm sorry.
I'm going to go ahead and do a few more things here. I'm going to go ahead and say is checked equals true. You see that the DOM box is red right now. And actually, if I misspell something here, the DOM knows that is checked is a valid property. That's fine. And then we have a bad value. So the object box wasn't able to load properly because the type converter for that Boolean property failed. If I correct that, that works fine. If I misspell a property, wouldn't it be nice if a XAML processor didn't just blow up the first time you had something misspelled and you could actually walk through it and know that it's unknown? So there, DOM box represents unknown things. My mouse is a little freaky here, sorry. DOM box represents unknown things with a different color. Now, actually, I think there's a lot of potential for an editing surface like DOM box here. You can press delete, you can insert things. You could do some pretty interesting editing gestures, I think, or visualizations that we'll have to explore over time. Now, the other thing you can do is you can have things like events. Checked equals foo. Let me fix this property over here. Now, you'll notice that checked equals foo, that works fine. That's an event. Everything's happy. The problem is that's not loaded over in XAMLPad. Has anybody ever noticed that when they copy and paste things from Visual Studio and paste it into XAMLPad, and if you had a button with a click handler, nothing loads anymore? Does anybody like to fix that? So Charles Petzold's in the audience somewhere here. He's got a XAMLPad too. It'd be pretty tough for him to go do that, to figure out what things are events. So we'll talk a little bit about maybe how we could process this stuff and process using this data model. So OMV plus types is our data model. OMV, we had a root object. Objects have members. Members contain objects or other values. Some objects are collections. I actually forgot one quick thing, sorry. I'll pop back over. I'll open up an example that is like the example I showed earlier. I've got 4 checkboxes here, 3 of them with hello, hello, hello. And this fourth one with an image. I'll hide the object box. So once again, those are 3 ways of representing the exact same thing. And in the XAML data model, they look exactly the same. No difference. Yes. And if we go look at the content property and press F12 of checkbox, we know, oh, this holds any object. I can put more than just strings in there. Maybe I should be able to put an image inside of there or something else. So down here, we have a checkbox, and we put an image right inside. And we set 2 properties on that, the source and the height. And there we see it's represented there as well. Now, stack panel's up here in the top. You can see stack panel has this nice little striping underneath it. It makes it look like stack panel might be a sergeant or something like that, right? Stack panel has a property. This is the children property. And if I look at the definition of that, it's a read-only property that is of type UI element collection. So we represent these collections even if you didn't describe them in XAML here. And so you see that there's a UI element type here, and it has an items collection as well. So that's how we represent collections. So our data model, objects have members. Member contains objects or values. You saw that checkbox .content holding an image or string value. Some objects are collections, like the UI element collection. And collections have a property that hold their items. But we're kind of cheating there. iDictionaries and iLists don't really have a property. They have an add method, and that's all good. So we pretend to preserve the OMV story. We pretend that there's an items property there. And then all of the system is typed. Objects have XAML types, so you can find out interesting things and do interesting processing. And members are instances of XAML members. So really excited to announce system.xaml DLL in .NET 4.0 that will make it easier to process XAML and make it easier for to build great new, to parse XAML from XAML to objects, to take objects to XAML, and a great new component that can be used by WPF, WCF, WF, and your components as well. We didn't make the .NET 4.0 on your hard drive, but we're in .NET 4.0 back in the labs in Redmond. We're going to be releasing next month a CTP of system.xaml that you'll be able to work with. You'll see the APIs in a second, but you'll be able to work with this. This CTP will be able to work with .NET 3.5 and run on .NET 3.5, so you'll be able to easily work with it and give us feedback on it.
Is this the thing that's going to let me process XAML like a DOM box?
Exactly. This is how we build DOM box.
Sweet.
Okay, so how do we do XAML to objects in 3.0? XAML to objects in 3.0, there's an API, XAMLReader.load in Presentation Framework. It takes in an XML reader or a stream, and it returns an object. And there's the API call is represented by this arrow. This arrow does three main things. It takes XML nodes and translates them to XAML nodes. It resolves type information. It figures out checkbox actually maps to system.windows.controls.checkbox. And it creates the object graph with whatever you've asked me to do. But it does all of those things in an unexposed sort of way. So in .NET 4.0, system.xaml.dll is going to give you a key difference. The arrow is going to be bigger. Well, it's only on this diagram, really. We're componentizing the innards of the implementation here. So when you call into Presentation Framework's old API, XAMLReader.load, that will call into system.xaml's XAML system. And it has one component that will take XML nodes and translate it into XAML nodes. So it'll take start elements and attributes and all of those things and convert it into XAML nodes, OMV plus types. The way it gets types is it uses a type resolution system that understands what XML namespaces mean in XAML and what assemblies are and how to find types. We have another component that takes XAML nodes and knows how to create an object graph. Now, all of these are interesting to mix and match in other scenarios as well, as we'll discuss. And we have a very small, what we call a XAML node pump. It's basically a little while loop where you call the reader and read one node, and you pass it over to the writer and pass it a node. And that XAML node pump allows you to tie things together. There's a lot of customization capabilities. First of all, it's going to be faster and more configurable. But you'll be able to do a lot of new scenarios. So I'd like to jump in and write a little bit of code. So we're going to close this XAML pad. And when the CTP launches, we'll ship this code as well and all of Dan's demos as well. So I'm going to build a textual DOM box. I just want to build a simple thing where I'll walk through the data model just to show you the API a little bit. So this control has a load method that takes a XAML XML reader. A XAML XML reader basically can take a stream or an XML reader and turn it into XAML nodes. So inside of this method, I'm going to build my little XAML node pump. Should be simple. I'll say while reader.read. And now I want to print out different things. I want to print out a visual representation of the different node types. So I'll do a switch on reader.nodeType. And I'll deal with the different cases of these types. Start object. When start object happens, I'll call writeLine. It's a custom little writeLine I've got here. And I'll say start object. And I want to grab the name of the object and display it. So once again, I just go to reader.type.name.
It's the name of the type of the object. Okay.
Yes. There's a lot more on that, and we'll play with that later. And then when I hit an end object, I'll just writeLine EO. Now when I get a member, a start member, I'll writeLine SM space, and then I'll grab the member name. Where would you expect to find that?
On something like member?
Yeah, reader.member.
Oh, okay.
.name. There we go. And we'll do our end member case. When we see an end member, we'll write down EM. And then we'll do one more case here. We'll do XAML node type when we get the value. These are string values in the typical case in this scenario, but they can be, actually it's of type object, and there's lots of interesting scenarios you can do with that. I'll write down V space, and actually I'll put quotes around it just to signify, hey, this is a string. And this is reader.value, has that value. And I'll put a close quote. There we go. I'll do the break. So we've got 5 node types that are primary node types here. Start object, end object, start member, end member, and this value. I've got a little bit of magic here. At the end of this loop, that writeLine function was actually pumping things into a string buffer. We're going to take the string builder, take the string builder, and put it into the output text, and we'll see it visually. So let's run this and see the first public demonstration of a XAML XML reader in action. Okay, so here we go. We'll bring up our textual DOM box, and we have a checkbox. And I'll say hello. And so there's a member named content with the value hello. That's great. And I'll go do, oops, oh, I broke it. And I'll do is checked up there equals true. And let me go do something unknown. Oops, deleted it again. And I'll do the checked event foo, and I'll misspell that a little bit. Now, right now, it's not showing that it's unknown or not. So let's just go ahead and make it so that the textual DOM box is able to realize when it's unknown and show a good representation. So over here in the start member, I'm going to create a string called member data and start off with it empty. And basically, if reader.member is unknown, then I'll go ahead and add, I'll say member data equals unknown. And we'll add that to the writeLine. We'll go ahead and kick that off. Now, this is just a simple example. Sometimes you need to go ahead and get much more complex data, and you might need to go ahead and look at another tag or something like that. Well, really, this is like XML Reader. You're doing one node at a time. If you need the information, you better remember it. You might use a stack and push the type and the members when you're getting them in the start object, end object, and those kind of things. So let's see if this is working now. We'll go back to our textual DOM. We'll turn off the object box. We'll add hello. And we'll mark something unknown. There we go. And we have an unknown member. So it's a lot easier to go ahead and process XAML, to understand XAML. The type system is just there for you, and you're able to go ahead and build and process XAML easily with a XAML XML reader.
So you just created a DOM box.
I created, it wasn't as pretty as the other one.
But I
awesome. created a textual DOM box.
Cool.
Yeah.
That was great.
All right, so the next step I want to do is I want to recreate object box. I want to just show you the basics of, well, how do you use a reader and a writer together? How do you use an object writer? And I'm going to show you a couple things there. So in object box, I'll go ahead and just delete that code, and I'll write this code. Now, I've got the reader passed into me in this function, so I need to go create a writer. I'll use object writer. Object writer, writer equals new object writer. Now, today we need to share a type resolver, basically our schema context between the reader and the writer, so I pass that in. We're looking at ways to make that not necessary. So I'm going to go write while reader.read. This is my XAML node loop. And I'll write in writer.write node. And I'll pass in the reader. And I'll do that for each node. So there, that's all we need to do to basically replace the functionality of XAML reader.load in the past. Now, this XAML reader, just to clarify a little bit, XAML reader is the new base class for XAML XML reader, BAML reader, and a few other readers. It's different than the static class that we had in .NET 3.0. So let's see if this is still working. And this isn't working at all because I forgot to do one thing. I need to go grab the result, and I've got an object. I've got a property named result object. What is my property name? Sorry. Output object. So just like the other guy, I need to go ahead and grab the end result from the writer, wire it up to the output object, and then it'll be displayed. Okay, there we go. We've got our monster checkbox, and it gets smaller. So that's a simple scenario doing that. Now, I was just talking to Charles Petzold beforehand, and he's got a XAML Cruncher application. And I asked him, hey, do you handle button.click? Can you put click in there or not? And really, we can't do that. It breaks. We say checked equals foo, and it doesn't load. It's not happy. It makes it so nothing can load there. So let's see how we can go in the middle of this node loop and just check to see if this is an event. So I'm going to say if reader.member doesn't equal null, and reader.member.isEvent. If so, that means I hit a start member of an event. And then the next thing I'm going to get is this little value and an end member. So I'm just going to go ahead and, ideally I'd use the skip function here, but we need to kind of fix it. I'm going to go ahead and call read twice. It was a communication problem. We're working on it. So I'll call read twice, and I won't call the writer in that case. Oops. However, if that wasn't true, if it's not an event, I'm just going to call the writer like normal. So this is going to filter stuff out. So you can filter things out. You could add things. You can filter things. You could do whatever you'd like. Let's see if we're able to successfully strip out the event here with the ability in the XAML node pump to add a little bit of processing, to use the type information that's provided on the XAML reader for me.
So last time there was a red arrow at the top that signaled there was an error, right? We're going to see if there's any.
So I can go ahead and say checked equals blah. And I can say hello, hello, hello. And
there's no error.
It's loading perfectly.
It just loaded it. All right.
So you get a lot more flexibility. And there's going to be a bunch of scenarios. Now, I'm not going to go demo this right now. But the next step you could do some pretty interesting things. Maybe you want to make it so you could F10 or F11 through XAML and just like send one node at a time over. That's pretty easy. A couple lines of code. You now can step through things because the object writer doesn't care. It's just going to go build its tree. There's a lot of scenarios that are possible now. So the recap of that demo is we used a XAML XML reader to walk through and process XAML. In one case, we just printed out information or analyzed information about it. In the other case, we used that in conjunction with an object writer. We wrote a XAML node loop and passed things through, and we showed some value add with being able to strip things like events. So XAML reader.load, you don't need to go program to the lower level stuff. Things will just get better. Things will have fewer bugs. Things will be faster. But if you need to go there, there'll be a lot of great capabilities there. So the XAML Reader API signature, I just want to reiterate this. XAML Reader is an abstract-based class. We used read. We looked at the node type. There's 4 payloads that are interesting. When you get a namespace node, there's a namespace declaration object you can see. And then for an object member or value, you get a type member or value. When you get an end member or an end object, you don't get nothing, none of those things light up. You don't get the type or member, so remember it if you care. There is a skip, doesn't work so great yet. There is a read subtree that works nicely. XAML writer, the only API we called on that was write node, and that has its own implementation. You pass in the reader, and it says, well, what's your node type? And then based on that node type, it calls one of these methods, the write start object, write start member, all of these other methods. So there's a very loose coupling there between these different readers and writers, which enables lots of great scenarios. If you wanted to, you could go ahead and talk directly to the object writer and just call these commands. You don't need a reader to. There's going to be scenarios for that. So we've seen XAML, we've seen objects, we've seen DOM boxes. What is a XAML document? We've seen the data model. Well, really, a XAML document is any collection of things that can represent itself as a series of XAML nodes. So whether you have a textual XAML file, a binary file that's a BAML file, or your own binary format, an object graph of CLR objects, or maybe an untyped DOM tree that is loosely typed like an XML DOM that has object nodes and member nodes, etc. Actually, the sample app has a sample DOM. We're not shipping a DOM, but you can play with the sample one we're shipping. So let's talk about 5 primary scenarios for reader and writer scenarios. And I've got the letters XBOD around there, XAML, BAML, object, DOM. Red, XAML and BAML, those are file formats. Yellow, objects and DOM, those are in-memory representations. And we've got our node loop in the middle. So the first scenario we'll talk about is XAML loading at runtime, X to O. You use the XAML XML reader, we saw this, and an object writer. Now what if you wanted to do what our current XAML writer.save does and go from an object graph and serialize to XAML? So XAML saving, going from objects to XAML, we have an object reader component that walks an object graph, serves up XAML nodes, and you could connect that with different things. In this scenario, you'd connect it with a XAML XML writer, and it'd be able to go ahead and write those things. Now, if you wanted to change the way those things are written, you go sit in the middle of the node loop, you replace a reader or writer, you've got a lot of flexibility there, lots of flexibility. Now, when we compile XAML to BAML, today you can do this inside of MS Build with a build task, markup compile pass 1 or 2 in WPF land. We're going to have a public API, a public BAML writer, to be able to go ahead and create BAML, and you can use BAML in new scenarios if you'd like. Now, this BAML writer and the BAML reader that matches it won't be shipped as part of system.xaml. It'll be a presentation framework.dll concept still. Now, once you have that BAML, the binary loading of this, you'd use the BAML reader and tie it to the same object writer, and you'd be able to reuse those different components. The fifth scenario is very interesting. Citer and Blend and folks that need to take XAML and have a design surface and maybe do source code preservation of XAML might do things like load XAML, remember line information, store information in a DOM, an untyped DOM. Also, they need to create the objects because they need to render the checkboxes and things like that. But then they keep data structures to correlate. This is the object that matches this thing, which matches that text. So you could do that with something like that. And that's the kind of thing that Citer and Blend do.
Citer being the Visual Studio designer.
Yeah, the Visual Studio WPF designer. So those 5 scenarios, those 8 different readers and writers, the ones on the right and the left, we're shipping in system.xaml. We'll have a sample of the DOM reader and writer, and the BAML reader and writer will ship with WPF in .NET 4.0. Now, you can use the same scenarios for file conversions. We saw already there's a rich set of converters. But a lot of those converters just convert from a file format like Visio or SVG and convert to XAML. Well, maybe I want to convert it on the fly. There's advantages to using system.xaml for something like a file converter. Let's talk about it. Maybe I have an SVG file. That's the bottom here, SVG. And I want to convert to XAML. So, hey, I could go build an SVG reader that knows how to parse SVG and represent it as XAML nodes in some XAML vocabulary. Perhaps WPF 2D would be a good choice, or Silverlight 2D. And then I'd tie it into a XAML XML writer, and I'd be able to serialize to XAML. Or maybe I want to take SVG on the fly in my application and download it from some enterprise store, a diagram of a building or something like that, and represent it in a WPF application. So I want to create WPF 2D objects or Silverlight 2D objects. And I don't want to go write it to XAML and then load it from XAML. I'm wasting time. I'd rather use 2 readers and writers instead of 4. So here, I just use the same component, the SVG reader, tie it into an object writer, and there we go. Now you could also do the opposite. If I had XAML and wanted to convert to SVG, you just use the built-in XAML XML reader, and you'd have an SVG writer that the file converter author would write. And you could do the same thing, going straight from objects that were WPF 2D objects, and you could save to SVG if you wanted to. So there's a bunch of new scenarios that system.xaml will open up. Our data model is strong. It matches the CLR type data model, if you can imagine that. The data model is objects, members, and values, and it's typed. System.xaml DLL is coming soon near you. Enables a bunch of new scenarios with a single API to read and write XAML, BAML objects. And it's a great foundation for file converters. And this is the URL which will eventually point to the system.xaml CTP that's coming this November. We'd love for you to try out the bits and give us some feedback.
Great. Wow. That's great, Rob. You can really see how system.xaml is going to make it easier to parse and process XAML documents faster. And it's going to enable a broad and consistent support for XAML 2009 language features, right? It's going to support XAML 2009?
It's got all of that in there.
That's sweet. Great. Let's take a step back for a second. And we can, over the past few releases of the .NET framework, you can really see how the core frameworks like WPF, WF, WCF, Silverlight have been creating more and more richer and richer XAML vocabularies. These frameworks are becoming more and more XAML ready. WPF really kicked it off in .NET 3.0 by shipping a rich XAML vocabulary for UI. You could then separate your UI from your code. We've got great tools now for WPF. Similar things happening in Silverlight 1. We had some initial XAML support for graphics and animations and media. Silverlight 2 adds more, richer XAML vocabulary with support for more controls and layouts. With Windows Workflow, also shipped a XAML vocabulary in .NET 3.0. Had some issues. We received good feedback from customers that there were things you wanted to do in XAML that you really couldn't, like handle certain events and share data between your activities. In .NET 4.0, the new workflow runtime will ship a rich XAML vocabulary for data flow and for callbacks. And even WCF. WCF had no XAML representation in 3.0. In 3.5, leveraging Windows Workflow, you could actually create a complete WCF service in XAML. It was very limited XAML vocabulary, but you could do it. In .NET 4.0, the XAML vocabulary is just getting richer. There will be a rich XAML vocabulary for writing a complete WCF service in XAML. I'd like to show you. Yes, I heard a show it over there. I'm going to show you how rich these vocabularies are coming by demonstrating an end-to-end app written completely in XAML. Now, my goal here was to not write a single line of code, but to only write in XAML. The application is going to be a stock advice aggregator. The idea here is that I want to consult multiple sources of stock advice and then aggregate it together to decide if I want to buy a particular stock. Okay? Here's the app. Let me go over here. So we've got a simple WPF app I just created using Visual Studio. It's going to allow you to enter in a stock ticker symbol and then click a button to request some stock advice. That's going to fire off a workflow, and that workflow is going to do the work for me of asynchronously calling my stock advice services and then aggregating the results. I then have a couple of WCF stock advice services, and the logic for how these services make recommendations is also going to be implemented in Windows Workflow. Okay? Let me switch now to demo. Here's the app. You can see that on Tuesday, I checked with my stock advisors about whether or not I should buy some stock. They gave me a strong recommendation Tuesday morning. It turned out to be a great thing. Let's see what they say about, I don't know, some food stock. They're going to request some advice. Oh, they're saying to wait on food. Don't buy food. What are they saying about Microsoft today? Buy. Okay, great. That's fantastic. All right, let me show you. Let's go to the app. So now for this demo, I've deliberately disabled all of the wonderful designers that we have in Visual Studio for WPF, for workflow, so that we can just look at the XAML. Beautiful markup.
We love those angle brackets.
Yes, we love those angle brackets. Okay. This is the WPF app, the UI. You see I've got a window and some labels and text box. Down here, you'll see I've got my button. And here is button.click. And you can see that I'm wiring up the event handler for button.click using this delegate activity thing. This is a markup extension that's in your PDC bits. It's a sample, actually. It's the WPF, WF integration sample. I just grabbed the existing bits, and you pulled it into this demo. Everything you see here will work on the existing PDC bits. So what this guy is going to do, it returns a delegate, and when you call that delegate, it will invoke the workflow inside of the delegate activity tag.
That's really cool. Inside of WPF, I've seen 2D and 3D and those kind of things inside of a XAML file before. But I've never seen a workflow, WF, embedded inside WPF. That's great.
Complete declarative logic. Let's take a look at the workflow. It's a sequence. And you can see at the beginning here, the sequence has some variables. This is how workflow stores state. And I can see that this variable is of type Boolean because it's a generic type, and the type is defined using the :type arguments attribute that we saw earlier, XAML 2009 language feature. The type is one of the built-in types. It's Boolean. And the name is allAdvice. So this is going to be the variable that's going to store the aggregate result of all my advisors. Okay? Now the guts of this workflow, the core, is just this getStockAdvice activity. It's a custom activity. It takes in a stock ticker symbol. And you can see I'm getting that stock ticker symbol using a workflow expression to refer to the text property of the stock ticker symbol text box from the UI. That's the better support for named references. And then the result of the getStockAdvice activity is going to be stored in that allAdvice variable that I defined previously. Now this getStockAdvice activity is a custom activity defined completely in XAML. The rest of this markup here just updates the UI based off of the advice. So let's go look at the custom activity. Here it is. You can see that I'm defining a new type using class called getStockAdvice. It is an activity. It derives from activity. I'm defining two new custom properties for this custom activity. The first one is named stock ticker symbol. It's of type inargument of string. We'll cut off there. And then the second one is named stockAdvice. That's the out argument of Boolean. Those are the two properties that we saw in the UI markup. Great. Now, I'm not going to go into too much detail in this workflow, but basically you can see that I'm using this parallel for each activity to loop through a list of URIs for the stockAdvice services to call each of them in parallel using this client operation activity. That's what's actually going to use WCF to send messages to my services.
Okay, so workflows, now there's a workflow object of some sort, this client operation, that calls a WCF service.
Yeah, it's just another activity, another WCF-based activity. Now you can see in this custom activity how I'm doing the aggregation of the advice from my advisors. The advisors basically hand me back Booleans. True means buy, false means no, wait, don't buy that. What I'm doing here is I have a variable that I'm just anding all of the advice together. Now notice that I can just look at the XAML and see what my stockAdvice aggregation process is. My application is transparent. I can see from the XAML which advisors I'm using. This transparency really makes your application easier to see, to modify, to share with others. Great, let's go take a look at the service. So that was the custom activity. I've got two services here in my project, stockAdvice service 1 and 2. Let's look at the XAML for one of those. Here in this case, the XAML is rooted with a service. Surprise, surprise. For those of you familiar with WCF, a lot of this should look pretty straightforward. A service has contracts. A service has endpoints that then expose those contracts. Here I have one endpoint And you can see that I'm referring to the contract that this endpoint exposes using the new x:reference markup extension functionality to refer to that contract by name. Great. Services have an implementation that implements the contract. Here you can see the implementation, and it is, of course, a workflow. The workflow consists of this service operation activity. That's what's actually going to do the work of receiving the message and shredding the data out and then replying. The guts of that implementation of what I do with that data is down here at the bottom in this assign activity. And you can see that this stock advisor is more like a magic 8-ball stock advisor, right? Basically, if the stock ticker symbol begins with an M, they say, yeah, that's great, go for it. Now, again, you can see,
That makes sense.
a little silly example, but again, you can see the transparency. I can just look at the workflow for my service and understand what it's doing. I can just edit the XAML to change it. The process is transparent. Now, the second service is exactly the same thing, except in this case, we can see, again, that this guy only recommends true if it happens to end with a T. All right, great. Let's go back to the app. So now, based on what you now know, if I type in moo, what's the recommendation going to be? Wait, let's see. Wait, okay. And if I type
because one guy said yes and one guy said no.
That's right. So
and you're anding them together.
Anding them together so we can, they weren't in agreement. And I only buy if everyone agrees. What if I say moot? What's it going to be? Buy. And what if I say Microsoft? What's it going to be? Buy. Right, great. So we've seen .pf, .f, .cf, all in XAML in a single XAML application. Great.
Very cool.
Yeah, yes, actually, if you go to some of the workflow talks, I don't know if they're actually showing it here, but it should be on your PDC bits that you can actually F10 through your workflow. Okay. And it will highlight the activities as you go through. So there is debugging support, and we're improving debugging support for the other frameworks as well. So where is this all going? Frameworks like .pf, .f, .cf, and probably many of your own are allowing application authors to just declare their intent for when authoring their applications as data. And this is great because it means that application authors can say more of what they want and less of how it's done. Now, to illustrate this, let me use an example. Let's say you want to build a house. Usually when you want to build a house, you start with a blueprint for the house. You don't start with a recipe for the house, a long list of instructions on how to build that house, like first lay the foundation, and then I would like you to put the framing on, and then if it's sunny, I'd like you to work on this, but if it's raining, put the roof on, etc. You don't need to do that because a builder can take care of all those details for you. A builder can take your blueprint and build you a house and make sure that it's stable, that it's secure, that it's built to code. You can build applications declaratively in a similar way. You can start with a model of the application component that you want, a blueprint of that component. You can hand it to a framework like .pf, .cf, .f, and your own, which can then turn that model into a running application. And we think that XAML is a great format for defining declarative models. And that frameworks should be designed to be XAML ready, to support XAML. Now, why would you use XAML? What does XAML do for you? Why make your framework XAML ready? XAML has a number of benefits. I'm just going to quickly go through. XAML is just XML. So you can leverage your XML assets, your XML knowledge, your XML tools to parse and process the XAML for storing it and dealing with it. Oh, let me go back. So ignore that. Markup, XAML follows the principle that markup equals OM, so there's a very straightforward mapping between the XML markup and your object model. This means that if you understand the object model, then it's fairly easy to write the markup. Consistency with .NET, we've seen that across .NET we're using XAML more and more, creating richer and richer XAML vocabularies. Users can use their knowledge of XAML from other domains like .pf, .f, .cf to understand how they can author in that format. XAML is more human-readable XML. XAML has a lot of features that make it easier to author and read, content properties, implicit collections. You'd be able to use compact attribute syntaxes and type converters. And this is really, as we saw in the demo, having transparent XAML is really important. It makes it easier for people to read the XAML, and it's easier to tool. You can get great tools using XAML, and we have many that we're building ourselves and many that you are. XAML has out-of-the-box support for code behind. You can compile your XAML with code, so you can support event-based programming models. And you can just ride the XAML wave. Microsoft is investing in XAML in many places, including Oslo. If you've gone to see some of the Oslo talks, the Oslo repository supports importing and exporting XAML into the Oslo repository. So you can query over it, you can look at it, you can deploy it. So WPF, WCF, WF, becoming more and more XAML ready, and so can you. And we encourage you to leverage XAML as a useful data format for your frameworks. So key takeaways from today: XAML 2009, shipping a lot of language enhancements. It's going to make it easier to author in XAML, enable more rich XAML vocabularies. System.xaml, we're going to make it easier and faster to parse and process XAML documents and transform them. There's going to be a November CTP where you can play around with the bits. Please do. And more frameworks are becoming XAML ready, and so can yours. There are a lot of great talks at PDC this week on WPF, WF, WCF, and a lot of them will highlight how they're using XAML. This is some of them. We encourage you to attend those. We would love to hear your feedback on this talk. Please fill out your evaluations, and we'd be happy to answer any questions that you might have. Thank you very much.
So we'll take questions now from the microphones, and then we'll also be available in the booth area for the next session as well. So
I'll be by the balloons. Rob will be by the WPF
booth. Yes. Go ahead.
Hi. I'm pretty new to XAML, so forgive me if the question's a little novice. But what are the benefits of the OMV types in XAML 2009 over just directly using the .NET data types like in XAML 2006? Just the namespace difference, right?
Well, so there, you mixed a couple different things. There's new language features that let you describe new things like name references and generics. We're catching up with .NET 2.0 to be able to describe generics. So we're just catching up there. And then the new data model is only if you want to start, if you need to use a reader or writer in custom form.
Yeah, actually, no, it was a simpler question than that. I mean, it was just about like the data types, like strings and ints and that sort of thing. In XAML 2006, you just bring in the system namespace to get access
There's
to
no advantage to saying x:string over sys:*string other than it's just a little easier to author.
Yeah, the type, we map the built-in types directly to the framework types. It just means you don't have to go, when you want to use a string, you don't have to go define an XML&S attribute and know how to write CLR-namespace, blah, 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 blah. You can just write x:*string because most people already have the XAML namespace in scope.
So there's no new feature or anything. It's just you just don't have to bring in that namespace.
It's an authoring convenience.
Okay, thanks.
Over there.
Hi there. So I saw the XAML readers and writers, and I thought that was pretty cool, very useful. But the way you were describing them, they look like a one-time file conversion. So you convert from one file format to another file format. I'd like to use them slightly differently. What I'd really like to do is to be able to tell Visual Studio, don't use the built-in XAML XML reader and XAML XML writer. Use an SVG reader or an SVG writer. Possibly just to change the XAML file format, but also to change the XAML location. At the moment, they're based in files. I may store my XAML in a database.
Sure.
Do you have any plans to tell Visual Studio and Blend to extend them to use different readers and writers?
We don't have any short-term plans to make Blend and Cider use readers and writers and do that, but that's great feedback, and we'll make sure that feedback in that scenario is forwarded to those teams.
So you want an extensibility point where I can configure which reader to use?
That's exactly what I want to do.
I mean, you can definitely do that at runtime. At runtime, you can go use XAML Services APIs, to go do that. But I understand in the designer, yeah. nothing like that yet. But that's
Okay,
I'd love
thank
to
you.
learn more about that.
That's one.
Hi, will system.xaml be available for Silverlight?
Will system.xaml be available for Silverlight? We're working with the Silverlight team that sits in the same hallway as me to make sure that their XAML parsing gets better and better. We would like a future version of Silverlight to have an API subset of system.xaml and to have the same great language features. It's a challenge to, especially when there's so many parsers and runtimes and tools, to evolve the language. So we're working across all the tools and runtimes to make sure that we have solid XAML parsing and solid XAML language support, great CLR binding information, great extensibility for type authors, all of those things. So we've got nothing specific to announce yet for Silverlight, but we're definitely, they're definitely interested in enhancing their parsing story there, and we're working closely with them.
Great, thanks.
Thanks. Yeah, far side?
Have you given any thought to addressing inversion of control and dependency injection using XAML?
We've talked with the MEF team and other teams about dependency injection, and so far we haven't thought of any XAML features that are needed there. We're going to have more discussions there. We'd love to hear your feedback about what we could do to our APIs to enable scenarios like dependency injection. There'd be scenarios, if you plugged the XAML schema context, you'd be able to somehow go ahead and create the type a different way. That instead of just creating it with a constructor, you could go choose to look up your 10 different rules about how you might go get that type. Oh, it's a singleton, go get that, etc. So there's some flexibility in the system now. We'd love for you to try it out. We've done some thought and some work with other groups, and we'd love to work with you.
Thank you.
In your end-to-end XAML demo, you showed your WCF service implementing an interface. Was that interface defined in XAML, or did you cheat?
I don't know if we could go back. Can I go back quick? Let me show it to you. It's not cheat. All right. So remember I said, here's the contracts. So in this XAML snippet, you see I'm defining in markup a service contract, and its name is iStockAdvice, and I'm in XAML defining an operation contract called getStockAdvice and defining the operation arguments all in markup. So the contract really is just data here.
So if I search for iStockAdvice across all things in this project, I wouldn't find a CS file with a little interface defined?
That's correct. There's no interface. Now, the one place you may say that I am cheating here is that the operation arguments do bottom out at system.type. So to specify the data type of the operation argument, I do have to have a CLR type for that currently. We're working on what makes sense there. Here I'm just using a built-in type, so it's part of the framework, so it just works. If I wanted to use a custom data contract, like a person data contract, we don't currently have a declarative way of doing that. You'd have to do it in code and then reference it as a CLR type.
So don't throw away your C# or VB books yet.
Yeah.
Thank you.
Still lots of scenarios for code.
Laurent.
Hey, that was a great talk. I hope you realize you just pushed Dr. WPF into total madness. I mean, responsibility is yours, right? I have a question about typed arguments and factory methods, and if that's the death of object data provider. Is that going to replace basically the object data provider?
We haven't had the full discussion with Sam, our key data developer. But there's a number of scenarios where people have said object data provider, you can go ahead and call this method and it doesn't quite meet their scenario. And Mark Bolter has said, oh, wow, that sounds like that would work well for that. Mm-hmm. So we're not going to go ahead and obsolete object data provider, but I believe that some scenarios it'd be interesting to go ahead and use x:factory method or x:arguments. So,
that makes sense.
Yeah.
Okay, thanks.
Great. Thanks, Lauren. Yeah.
Hi. What's your thoughts about merging multiple XAML files into one, like partial classes or XML include?
Right. Yeah, great question.
So you want to have multiple XAML files and be able to somehow create one XAML graph or something?
Yeah, we've got a feature on the drawing board that right now isn't planned for XAML 2009, and we're debating whether it should ever be in the language or not. There's a bunch of issues by adding include to the language. Some languages choose not to do that kind of thing. So we're not sure where we're going to land on it yet. Oftentimes, it makes sense for domain-specific environments to just enable hosting of other things. For instance, WPF's frame has a source tag, and image has a source, and even though it's not XAML. So oftentimes, a component will have the ability to reference another XAML via URI. That's the plan of record right now, but we'd love to hear your feedback and scenarios about that. So please come up afterwards, perhaps, or send email.
All right, thanks.
Yep. Where are we going back to now? Right here?
Regarding some of the early implementers of XAML, like MyXAML, they have a very good dependency injection framework as well as a very rich nomenclature on the syntax and other things. And then Spring also came up with their own syntaxes. Is there any way where you are thinking of standardizing those things? Because there are a lot of people using different kinds of frameworks.
Yeah, well, like we answered it for the earlier dependency injection framework, we haven't figured out, other than the extensibility of our XAML schema context, which can find types, we haven't figured out ways we need to change the language yet. I haven't looked at MyXAML since 2004, so I don't know the exact syntax there. We'd be interested in understanding the scenarios you want to achieve and making sure that our system works well with it. But we don't have any current plans other than to continue discussing with the MEF team and other teams and customers.
Okay, thank you.
Yeah, I've got a question about the relationship to Oslo. You were talking about that everything can be imported and exported into the repository. But what about actually creating a textual DSL which is much more concise than using the XAML? Because
I think that sounds like a great idea. There is a talk by Chris Anderson that I don't know if it's going on right after this or
it's a lunchtime session today. I'm not sure where. It should be on the schedule.
That you should definitely go see that talk. That'll be specifically about DSLs. Now, XAML...
He talks about something like the death of angle brackets or something like that.
Oh my God. So today, our runtimes and our tools are based off of the XML format for XAML. So XAML has life. The repository can import like a workflow or a service in XAML. Maybe you've seen some of those demos in other Oslo talks. So I believe XAML is still a first-class citizen in this world. But obviously, although it's human-readable XML, it's not that human-readable. And it certainly makes sense to define a domain-specific language for your domain that you can then maybe generate XAML from and then use that to load in the runtime. Absolutely.
Or basically directly import it into the repository.
So, potentially. But, I mean, yes.
So are you basically going to deliver an M schema for the whole XAML stuff?
Are we going to deliver? And right now our approach is to model the domains, not the XAML data model. It may be interesting to do that as well. Like if you look at the schemas in the bits that you have, I believe, you'll see models for workflows, models for services. You can imagine models for WPF. So we're not modeling like start object, start member. That's the approach we're taking right now because we think that people want to look at the models, they want to understand them, and that's the level of abstraction that we thought would be most common.
Okay, great, thanks.
You showed an event handler that may or may not exist in your samples.
It definitely exists. WPF, WF integration sample. Well, it's just, yeah.
But the event handler doesn't have to be connected.
You're talking about the button.click in his integrated demo?
Yes, where the event handler...
well, the event definitely did exist. The click event had to exist, otherwise we'd blow up. And then there was a markup extension there. And so the XAML XML reader parses that and just says, oh, I've got a member. And then, oh, I've got a markup extension. And then the object writer gets that and will populate the markup extension with whatever data, including the whole workflow if necessary, and return a delegate and wire that up to the click event.
So did that depend on having an X class on the window or?
There was no. All I did was load. I didn't need to compile that window. If you look at window 1, it didn't have an XClone class. attribute on it at all. I'm actually just loading it directly up and calling show.
So markup compilation today, the .g.cs files, .g.vb files, that's where we do event wire up, name wire up, those kind of things. Well, that still will be possible and will probably still be the default. If you want to have a XAML file with events, with just either named events like Dan said in this slide, it will look at the root object, look for the right named delegate and wire that up. Or you can do the more advanced markup extension. Or you could sit in the middle of a node loop and take whatever thing you want and say, oh, well, he's saying foo. I need to do something crazy and go create some other delegate. So there's a lot of different ways that you could go customize the wiring of events that don't work today. You can't have no flexibility today. Great. Thank you. Thank you.
Do you plan to bring an eval extension into XAML?
Eval extension.
Like Dan was showing with the square brackets?
Yeah.
I mean, so Dan demonstrated the evaluation, basically the type converter that made use of markup extensions and had some basic expression language and things like that. So why don't you describe what that is?
Yeah, sure. So in work, those were workflow expressions. They're specific to workflow. It's not a generic language feature, at least not at this point. So all that workflow did is they wrote a type converter that knows how to parse that string. They make use of the various services that we provide in order to do name resolution, in order to get the objects that you're referring to by name, and they just parse the expressions and know how to execute them. So it's a component that you could actually write yourself. If you want to make up your own name-based expression syntax, you could do that. The workflow one happens to be VB-based. You could write one that for...
We're making it easier now. Instead of markup extensions and type converters in .NET 3.0, there were 3 different services that were provided to you. URI context to find out the base URI. I provide value target to find out the object and the property that you were trying to set. And XAML type resolver. We're now adding a bunch of things. So XAML name resolver to be able to do name resolutions. So if you wanted to refer to names, the ability to get the root object, the ability to get more things with namespaces, we've opened up a bunch of other scenarios. So the flexibility of markup extensions and type converters is much richer.
That's great. Thanks.
Great. Thank you.
We're out of time.
Okay. Yeah,
Thank you very much.
Thanks very much.